Hi students, let's continue from where we stopped. Right, remember we are introduced to a new topic, the eighth one, that's about the transformation. Right, so please first, before you join us, can you please make sure you go back to the previous videos, you revise what we did, and for sure, if you have some who have just joined us, please don't rush into the second section. Right, that's the second lesson. First of all, understand what transformation is and all other areas that we discussed, so that what we have today should be meaningful to each one of us. Please, there's a link down here. Right, so now in this video, we are just simply going to be introduced to what we call the translation vector. Like, by the term itself, translation, remember, we are just talking of issues that involve displacement, change of a position of a point, could be the figure from one position to the other. That's about it, translation. Right, now it's about a vector. Right, if you talk of translation vector, here we're talking of the issues on how something, being it a point or a figure, is moving. Right, we understand the definition of a vector by what we learned in physics. We define vector as just like a quantity which has got magnitude and direction. So like here, it's true, whatever we do about the translation here is an issue related to both direction and magnitude. There's no way you can talk of translation without considering issue about what? About direction. Like, so a vector here is really meaningful each time we talk about what? Translation. So here, what is it about this translation vector and how can we find this translation vector in all the areas that involves the what? Talk of a change of position. Could it be a point or could it be what? A figure. Right, so here I'm going to define and be able to explain it to you how we can come up with this vector or describe this vector that brings in more, the issue about the change of position. Right, now for example, as per what we discussed previously, we are looking at the displacement of a point from one position to the other. I'm going to use the same scenario to introduce the translation vector. Right, let's, for example, we have a point that is moved from a position where we have got x. Let's say we have got a point A, moved from this position where x is 1 and y is 3. And if we allow this point to translate or simply to change a position to a position 5, where x is 5 and y is 6, right? So here x is 5, y is 6, right? We'll be able to see that if A moves from this position to that position, it means whatever A will have here, that now will be described as what? An image, right? Now, what will happen here, or we should take this, what has happened here? If A is said to be moved from this position to that position, it will be a situation that first can be presented by a direction to something like this. We go upwards like that, and arrow can be indicated that way. Right. Now, if we are to describe this arrow here from A to A prime, you'll be able to see that this movement here, from this position to that position, has something to do with the x and y axis, or has got something to do with the movements along the x and y axis. Right, how can we describe it? Look at this. Marks that are moving from A, which is found at 1, 3, is as good as at 1 on the x-axis and 3 on the y-axis. But I'm here. Once I'm here, is as good as I'm here on the y-axis, where y is 3. And when I'm here, when x is 1, is as good as I'm here. So if I'm moving from here up to that, is as good as I'm moving along the y-axis upwards. And I'm moving along the x-axis to the right. Look at that. I move from here, is the point, y is 3, x is 1. And now as I move, it means I'm going to occupy a new position here, or A is going to occupy a new position here. So if you look at this new position here, you find that now the value of x is what? If you check down here, it will be 5. We check off y here, it is what? Is 6. So just like when we can try now to relate the movement from A to point A directly like that by that arrow, it will be like I've moved from here up to that. And I've moved from here up to that. That is now along the y and the x-axis. Right. So, which means in this case, this arrow here defines number of units which has been covered along the y-axis, along the x-axis. And the same arrow describes the number of units which have been covered what? Along the y-axis. So it is just a line that defines two quantities at the same time. Quantities about the units on the x-axis and quantities about the units about the y-axis. So if you can count from this up that, you'll be able to see that when you move from here up that, it's just as good as I am at 1 here. It means I'm going to count from 1 now up to 5. You can look at here. Here x is 1. Here up x here is 5. So it's as good as I'm 1 up to 5. So I found that I've covered 1, 2, 3, 4 units. So it means along the x-axis, I've covered that is 1, 2, 3, 4 units. And if I'm going to check on the y-axis here, it is as good as when here we say y is 3, is as good as having here at 3. I'm at this position along the y-axis. And here now, if the y is 6, it means it's as good as I am that position where y is 6. So if I'm to move from here up to that, and I want to describe the movement along the y-axis, it needs just a matter of counting how many units have I covered from 3 up to 6. So here you count, say 1, 2, then 3. So that tells us a story to say that along the y-axis we have covered 3 what? Units as such. That's upwards. Right. So both of them are just like to the positive direction. Remember, if you connect to what we discussed in the previous video, it means here we're moving upwards along the y-axis and to the right along the x-axis. So it's always positive and positive. So positive units as such. And it means somewhere if we are diverted to the left and then down, the values that would have always be attached with a negative because those are the negative directions. But as of now, let's consider the situations as they are in order to define what a vector is. Right, so here we are saying from A to A prime, we have covered 4 units along the x-axis and 3 units along the y-axis. So what does this mean? It means this line here is defined by these two values, one for x and one for y. Right. So how do we present such type of light up? When you consider these movements here, in mathematics, it means this one is normal for all kind of displacement. If an object is going to displace or translate on the Cartesian plane, we have to always consider how many units has that object or point has covered along the x and y axis with the same activity that I've just done on the board here. Right. So you have to at least present this one in such a way that this one has to be described by that. So how we present this, these two values for x and y, we always write them in the form of a column. Like here we understand that the values talk of the units here for x is 4, units for y here is 3. So this is well written as this, like a column. We write one number on the top, and this first is the top number describing the movements along the x-axis. And as we talk of this example, it means the value of x here is 4. And down here we write another number that talks about the movement along the y-axis. So when you write 4, 3 in the column, this defines the movements along the x and y axis and the x and y axis. Right, telling us how many units have been covered along the x, how many units have been covered along the y axis by what I've just demonstrated here on the board. Right, so this what we have here is what is defined as the column vector. So if you talk of translation vector, we talk of a situation whereby a point has to cover a certain number of units along the y-axis and a certain number of units along the x-axis. So it means A to A prime has covered these units. Right. So the vector that is controlling this movement from A to A is a vector defined as 4, 3, like that. Right. So one way sometimes, if I do just have a point like A here, and I want to find the coordinates of A, if I've got a vector like 4, 3, given, that I will know for sure, it means A has to cover 4 units along the x-axis, and the same A has to cover 3 units along the y-axis. It means the coordinates for A, talk of the image of A will be like 4 plus 1 and then 3 plus 3. Y added with Y, X added with X. As such, you're going to get 5 and you're going to get 6 for that sort of the X and Y respectively. So this is the column vector search. Right. Now, similarly, if I can have another point from what I've just explained here, if we may be told that, say, we've got a point, say, for example, a point M at this position where X is 2 and Y is 2, and we are told that this M, M, 2, 2, is translated by a column vector. So, for example, we have a column vector talk of -3 and then 5. You might be asked to come up with the talk of the coordinates of the image of what? M. You have point M at this position. X is 2, Y is 2. They say it's translated by a vector -3, then 5. Then here they say find the coordinates of the image of M. It's just like now, what is the new position of M? So the result of the new position, okay, the result of the original position after, okay, the original position has been moved to a new position. That is just like an image. So what are the coordinates of which? At what position is this one going to be? So now, the moment that you're given this vector, it tells you that it's just like telling you how much has this point now going to cover? How much is that point going to cover? And where is it going to be? So there, you can be able to understand by what we've just discussed in here, that you can be able to use this vector here to come up with the new position of M, which is the image of M. So what it tells us here, just like we know that this is the value of X, and again here, this top number here tells us how much has that point going to cover along the x-axis. So what you do just have to add, in this case, to talk of just like it 2 should be added with what? -3. A negative here always just tells you the direction, has got no effect, but rather there it tells us the point is covering 3 units. But now the negative, it tells us it is covering 3 units to the left. That's just like the left. So left is just like a negative part because you are decreasing along the x-axis. But here it doesn't mean that the point is covering -3 units, no, but it's covering 3 units to the what? Negative. That's the decreasing part on the x-axis. So what will be the new position in this case? It means now this point will have a new position whose values of x it will be equal to 1. And now what about the value of y as the coordinate? For M, you also do the same. You just add 2 plus a 5 and you get what? A 7. So which means the image of M will be at a position x is 1, y is 7. So you're going to indicate there M prime is equal to 1, 7. Right. So that's the way the issue about the column vector, or talk of the translation vector, which is the form of the column, works. So it's just like a description of how much units are covered along the x-axis and along the y-axis. Right. Another simple way how you can find, we can work out this value of the vector 4, 3. You can just do it in another way around that the mathematician can be able to tell. Unlike you counting to say at A here, we have got 1 on the x-axis and here we have got 3 on the y-axis. Then we count up to 6. You say 1, 2, 3, and here we count 1, 2, 3, 4, and we have 4, 3. What you can do sometimes, you can just subtract the coordinates of the object, which is A, and the object of what? And the talk of the what? The coordinates of the image. So it'd be like the coordinates of the image subtracting the coordinates of the object will give you the value of the vector. So like here, look at this. Instead of counting 4 units along the x, 3 units along the y, you'd be like talking of this vector you'd say vector, in this case, that's the translation vector. It would be like, just like 5 should subtract what? Talk of a 1. So you come here, say 5 minus 1. And then talk of 6, subtracting a 3, you write 6 minus a 3. And what you get here is 4 then 3. Right. So what you do here, that's the way we work. But please always remember, do not interchange. A value that is meant for x should be always on top there. And the value that is meant for what? For y should always be down. If you write the y on top there, to us to consider that the number on top there, it does not mean the number of units covered along the y-axis, but it will be their number of units covered along the x-axis. So please, let us try to understand how we present our write-up in issues about the translation vector. So that's it. We are what we can say about translation vector, and we really conclude about this as to say every transformation in the Cartesian plane has to be defined by a movement along the x-axis and y-axis, and that defines what? A vector. So everything that happens here is there guided by a particular vector. I think this one is very clear to each one of us. You can just subtract the coordinates for the talk of the image and the object. You find the what? Talk of the translation vector, or else just count the number of units covered along the y-axis and also along the x-axis. But each time you do, remember for the y to be down, for the x to be on top. But don't write like the fraction like that. No, this is not what we are saying here. Right. Connected to that, what we also need to know, there's a lot now, but instead of now having a point, I would feel like now we have at least an example where we can see the entire now figure, which I've got several points, can be translated on the Cartesian plane. Right. Let us have this example here. I think before you look to that, can we have this example? How we can work out on it? Right. I have one question here. I feel like we can discuss together here. As you're watching, hopefully you have got a pen and the paper you're scribbling down there. Alright, so here we have an example only one. For this part here, we have got a translation. Translation, that's a t, is given as -2. And then 5. Right? So here they're asking us to find the image, find the coordinates, not the image, find the coordinates of the image of a triangle that is ABC with vertices A 0, 2 and B -3, 4 and the C, the coordinates are what? 2, 6. They say under a translation T. You see that? Under a translation T. What is the coordinates of the image of this triangle? So talk of the under T. Right. An exam expects a type of questions to come. Right. we have been introduced to the translation vector, and really we know, like here, if we are given that the t is a vector talking of -2, 5, you should be really certain to understand what that one means. So I think by what we've just done previously, you'll be able to know that when you write -2 and 5, it tells you that this particular figure is going to be moved along the on the Cartesian plane by 2 units on the negative side of the x-axis, and it's also going to cover 5 units on the positive direction of the y-axis. So just like it moves 2 units on the left on the x-axis, and also talk of the 5 units to the upwards on the talk of the y-axis. So just like, where would this triangle now be? A triangle with vertices, if I'm going to draw in that Cartesian plane, so it would be like A, B, C, like this, where my A is at what? A is at 0, 2, while C is at talk of 2,6, 2,6, while B is -3,4. So they say this triangle now is going to be translated. So it means that particular instance, we will define this one as an object, right? So this one, if it is going to be moved and be fixed on somewhere else by this column vector, then that one now defined as what? As the image, right? So now where will this one be? We can understand that one just by the coordinates themselves, right? So this area, we have been introduced on how a single point can move. Then here it means when we talk of this one, the whole of this triangle to be translated, it means we have to be there significantly looking at the movement of every point. Now it be just like a point at a time, right? So where are we going to be? So we begin with A. So what you do here, it means we are going first of all to work out the image of A. After that, you work out the image of B, then the image of what? C. At the very end, just connect those points. Then what you have is the triangle itself, but that does not change its size or shape, right? And you find that one as the what? That's the image. So let's see and find out the coordinates of A, right? So if this one is going to be translated by this vector, it means A will be found under this in position. So you write your A here, has got coordinates like 0, 2. And now if you like to find the image of A, you write A like that, the coordinates of which will be equal to, you talk of the original one, the value of x is 0, right? So which means if this is going to be translated, you look at the value of what? X here. How many units have been covered along the x-axis? So it means 2 units, -2 units. So you are going to means you are going to add with -2. Then write a comma, right? And for the y, you talk over a 2 here to be added with what? 5, right? It means it is moving 5 units from the position of a 2 in this case. Right, so what we have here, it will be like the image, the coordinates of A, point A will be equal to that talk of 0 plus -2, you get -2, then comma 7. This tells us if this one is going to translate, A will be found now at a new position, which is -2, 7. Where will be the position of B? B has coordinates -3, 4. Where will it be? So it means our B, you represent it by B prime, and this one will give us what? -3 plus -2. This is the value of what? X. How many units have been covered along the x-axis? Then comma, you get for y. Y here is the 4. That 4 should be added with the units to be covered, which is 5. And that, what do you get? We have -3 plus -2, that give us -5, then comma 9. So this is the these are the coordinates of image of a B. That's now B prime. And lastly, where are we going to have a C? C originally is at 2, 6. Then now the image of C, that's now like C prime, it will be equal to 2. That's a now plus minus 2. Then comma, it will be 6 plus 5. So this one will be found at the position, that's a what? 0, comma, then what? 11. Right. So if we were to conclude there, you'll be able to tell us that, say, therefore, the coordinates of the image are what? You talk of A prime, negative 2, 7. Then after you talk of B prime, you talk of what? Negative 5, 9. And lastly, you talk of what? That is C. Found at what? 0, 11. So this is your answer. Right. So you can see how we have just used the knowledge about the translation vector. Hopefully we are all following this one very well. Right. So that's it about today's discussion. We have learned something about the translation vector in connection with what we have just done previously in the previous video. By the link here, you can at least go through that, where we learned that the point can translate on the point on the on the Cartesian plane only if it has certain number of units along the x and certain number of units along the y-axis. Right. So that's it. So try to go through all these areas and be able to appreciate that the transformation is not all that difficult. It's just simple as it is. Right. So in the next video, we are going now to have a few discussions, particular questions that now where we need to present everything on the Cartesian plane, because here we're just calculating the coordinates of the image after translation vector. Right, but now we may have questions whereby they might ask you even to draw both the image and the object on the Cartesian plane. So there we have to look at that one more detailed and try to understand the tactics that needs to be followed. Before I leave, let me just give you this simple assignment. Comment briefly where you are. Right, draw a rectangle K N B X. Right. This one is found at 1,5, and this one is found at 1, this point is found at, this one is found at 1,5. This one is found at 1, negative 2. This point is found at 4, 5, being it a rectangle. This one is found at talk of again 4, negative 2. Right, it's a rectangle. Right, so what I want you is to find it. That's the coordinates again. Coordinates of a rectangle KNBX under a translation vector of which is defined as maybe vector Q being equal to 7. Let's not give you bigger values. Let's have talk of negative 3, then here negative 5. Right. So find the coordinates. If this one is going to be translated on the Cartesian plane, what will be the coordinates of K, N, P, and X? Otherwise, thank you very much for being together. Always reminded to go through by the link down here. And it's very, very, very important. Your comments are all welcome because we're here for you. Please go through whatever you have. Let us know. Link down here has to be yours. Thank you.